Hello, Facebook fans and YouTube fans of DX Engineering. It's Thursday afternoon here in the Eastern Time Zone in the USA. It's 1830 Zulu on June 30th, 2022, and it's time for the Manufacturer Showcase. And this is a show where we feature one of over 160 different manufacturers that DX Engineering represents and sells. And today we have Penta Laboratories on, and these are the tube guys. And Peter, welcome to the show.
Thank you. Hello.
And Peter, why don't you tell us a little bit about Penta Laboratories?
Well, Penta Laboratories was originally founded in 1950 and was making pentodes. At that time, we were developing pentode style tubes, which is a 5-element tube. And over the years, that we've transitioned more into just sort of the mainstream products, the triodes and the tetrodes that are still popular today for various usages. We sell a pretty wide range of products, from small tubes, receiving tubes for audio, all the way up to some military and medical tubes that are, pulse magnetrons, for example, and some tubes for MRI applications, things like that, and a lot of ham radio tubes, of course.
So, where are you located?
Well, our corporate offices are in Moore Park, California. And so, we have the warehousing here, and the testing and distribution is all in California. And we have manufacturing in China. Most of the product is made in China now.
Okay. So, Penta has always been a California company, right?
I don't think it was originally. I think originally it was on the East Coast.
Okay.
We've been doing Penta since about 1988 or 1990, something like that. Prior to that, it was run by other people. I wasn't involved in it that early.
Okay. And so, do you see the website here, Peter?
No, I don't see a website at the moment.
Okay.
There it is. Yeah, it just came up. Yeah, there it is.
Came up. Okay, good. So here's the 572B, which is a very popular tube for amplifiers. There's several manufacturers of amplifiers make the 572B. You want to talk about the 572B?
Well, the 572B is, obviously a triode, and it's a glass radiation cooled triode that's designed for grounded grid amplifiers, and it's a derivative of the 811A. It has a carbon graphite anode, which increases the heat dissipation a little bit, and through the use of ceramic insulators instead of the mica insulators internally, it has a higher voltage rating. So the combined higher voltage capability and dissipation rating allow for more power output. So you can use 2 or 3 of them. I think you can get legal limit amplifiers with 3 if you want to push them a little bit. So you can get quite a bit more power that way, rather, compared to the 811A.
Right. But what's nice about this is there are several amplifiers that use 4 of these.
Right.
And so this is a match set, and it says it's a direct replacement for the 811A, as you point out. So this is a heavy duty replacement, right?
Yeah, essentially the grid and cathode are essentially the same. So the mu and the transconductance and the power gain, that kind of stuff is all the same. So the additional power comes from, if you take advantage of the capability of being able to have higher anode voltage, and and therefore you have a little more dissipation. If you substitute the 572B in an amplifier that was designed originally for 811As, you won't get any power increase. You'll just have a cooler running tube, and so it will last longer as a result.
Right. So this is a good replacement for that. And of course, you do have the 811As as well.
Yes,
here.
yeah, we still make and sell the 811As, and they look similar, of course, to the 572B, except they have a metal anode instead of the. Here's one here. It has the metal anode instead of the carbon graphite anode, but the basic shape of the glass is the same. I don't know if you can see it. There it is.
Right.
And put it on this side. And, so it has the metal anode instead, and it has mica insulators, as I mentioned, and so on.
And the 811A, Peter, is quite a bit less expensive than the 572B.
Yeah, that's because of mostly the difference in the anode. The carbon graphite anodes,
Right.
are more expensive to manufacture, and the insulators, the ceramic insulators, are more expensive as well.
Now let's talk about the 3500ZG.
Right. Well, the 3-500 ZG is also a zero bias triode. It's a bigger tube. It'll handle quite a bit more voltage and has a 500 watt anode dissipation rating. And I think with this tube, you can get a legal limit amplifier with one if you really rail it, but it's really better to use two to make sure it's run conservatively. And there's quite a few amplifiers out there that were designed around the 3-500.
Yes.
Yeah.
Yeah. And a pair of these really is the thing for even, well, you can get 1500 watts out of a pair, but this has got a ceramic base. And is this graphite as
yeah,
well?
this one also has a carbon graphite anode. The original
Yeah.
3-500Z was a metal anode, and the ZG is a graphite anode. So it doesn't really increase the anode dissipation rating specifically, but it helps even out the heat on short-term overloads. So it's better for, like when you're tuning up the amplifier, or for guys that push them a little bit where you can overload it a little bit for push to talk kind of thing. But for CW, it doesn't really help you with the dissipation rating.
Right. Right. And here's my favorite tube. This is the tube I use in all my amplifiers here. There are 20 amplifiers here at K3LR that use this tube.
Right.
And that's the 8877.
Yes, the 8877, which is a metal and ceramic force air cooled triode, also zero bias design. And this is a oxide cathode, whereas the others we were talking about are filamentary types. This one has a oxide coated cathode. And this tube, you can get a legal limit amplifier with one tube without any trouble. And this is one of our most popular tubes. We use this in, not only for the ham radio market, but it's used in some of the MRI equipment and other analytical stuff as well.
So there are still MRIs that use the 8877 in use?
Yes. Yeah. There's a fairly large population of MRI equipment out in the world that was designed around the 8877, and they use the 3CX800A7 as the intermediate amplifier to drive the 3CX1500 in the output stage.
Okay.
And there's also a bigger MRI amplifier that uses the 3CX1500 as the intermediate amplifier, and a 3CPX5000A7 in the final.
Okay.
Yeah, so those are bigger system. They have I don't know, higher Tesla, the bigger coils and stuff for better resolution for the imaging.
Right. And you have the 3CX800s, which is also a popular amateur radio tube.
Yes. Yeah, they're very good for linear amplifiers, and they were used extensively in broadcast as well, for FM broadcasting, so on at one point, and may still be in some places. We don't sell a lot into the broadcasting market anymore. And but yeah, those tubes are still popular, and we make a lot of those.
Yeah. So, and we've got various derivatives here of, the 811s, a pair of 811s.
Yeah, they're available in various match sets. We can match any number really. If a customer wanted to get a large number, we could match them up on a special order basis. But pairs and trios and quads are the most popular.
Right.
I don't think there's too many amplifiers that would require more than 4, but we can match up whatever anybody wants.
And Peter, let's talk about life. How long are these tubes going to last?
Well, the life of a tube is generally talked about in hours, and So you should be able to get a well-made tube would do 5,000 to 10,000 hours. In the case of the 3CX 1500A7, the MTBF in the MRI equipment is over 10,000 hours.
Nice.
That's been pretty well demonstrated. There's a large enough population of equipment that in the world that's well established. In the case of the filamentary tubes, they can get similar life, but they're a little more prone to filament burnout. And even if you're not running the tube a lot, just the filament evaporates little by little over time. So,
right. Now,
whereas the oxide tubes don't have quite a well-defined end of life point.
You see the Alpha 77DX amplifier
Yes.
back there, Peter. That's got an 8877, a 3CX 1500 in it.
Right.
And the date code is 1978.
Yeah. Okay. So it's been there a while.
It's been there a while, and I use the heck out of it, and it has been a great amplifier. But when you talk about life of tubes, if you treat them right, filament voltage. How important is filament voltage?
Well, filament voltage is very important because the filament voltage sets the operating temperature of the cathode. And if you over voltage the tube, then the cathode wears out too early because it evaporates faster in the case of the thoriated tungsten type of tubes. In the oxide tubes like the 8877, it does drive off the barium faster, but it doesn't really achieve any better performance from the tube anyway, so there's no benefit to it. And you're really better off running the thing at the rated voltage based on the product data sheets that are provided. I know some people like to run the filaments a little cold, thinking they're going to increase the lifespan of the tube, but I don't think that's really actually true. Not very much. You can only go down a little bit anyway, and then the emission declines from the lower temperature, and you're not going to get the peak performance, the peak current you need to get the full power. So you really need to stay at the recommended temperatures for the tube in question.
Let's see. We've got a couple of comments here in the chat room, Peter. It says, I see Penta is producing tubes that were formerly on unobtainium, like the 4CX800 and the 3CX800. And are these going to continue to be built and stocked at DX Engineering? As long as Penta is making them, we will stock them.
Yes, we make those. The 3CX800A7, as I said, is part of the MRI family of tubes. So there's a good usage of those tubes. So it should go on for the foreseeable future. The 4CX800A7 is also currently made in China for us, and we have no reason to stop making it at this time. So should be supported for a long time.
Great. Well, Peter, thank you so much for coming on today, and thank you for making these tubes too.
Oh, you're quite welcome. Thanks for having us on. It's a pleasure.
The 572 and the 811 are so popular, and the 3500. Do you have any amateur radio operators that work there?
No, we never have actually had any ham or amateur radio operators here. I'm not a ham radio operator myself. I understand how they work, and I've run them a little bit. We have a few that we use for tube testing and other things like that, but never on an antenna, always on a dummy load.
Right. Well, I guess it'd kind of be a dream place for me to work would be because I'm a tube amplifier kind of guy, and
sure.
The 8877 I've got over here is a single band amplifier.
Okay.
And most of my amplifiers here are single band 8877s. You put 4,000 volts to that triode, and boom, you got an amplifier.
Yeah, indeed. Yeah, that's a nice simple amplifier design with the tubes like that.
The guys at IMAC, when they originally did that tube, that they were hams, and
sure,
so it was but I'm so glad you guys are doing it, and thank you so much for partnering with DX Engineering, and we look forward to a lot of business from our customers for Penta. So thank you so much, Peter.
Oh, thank you. You're welcome. And thank you for having us on and letting us talk about our products that we're so enthusiastic about and proud of.
Okay, we'll have you on again.
Okay, great.
We'll light up some tubes. Thanks again, Peter.
Thank you.
And 73 to all the viewers. We'll see you tomorrow for the weekend special.
Okay, bye.